Hello, everyone, and welcome to our next virtual coffee talk series. My name is Beray, and I'm the founder of Cubitra. So today, my guest is Kasper from Toit, and we will be talking about cool stuff for developers, for our partnership, and also about how we improve the IoT landscape together as being founder of two startups. So welcome, Kasper, again, and thanks for your time. So
Thank you.
would you mind doing a quick intro, just like doing to me in real life, because this is virtual. I know it's hard, but that would
Yeah,
be
no,
great if we can initialize the chat.
yeah.
Who are you? What are you working on? So
Let me give it a shot. As you mentioned, my name is Kasper. I'm a software engineer gone startup founder. I used to spend more than a decade working at Google building the Chrome browser and the JavaScript engine V8 that we put in there. So I've been working with programming languages and implementation of those, making them fast for almost too long. But a couple of years ago, I decided it was time to spend my days on IoT, small embedded devices that communicate with the cloud in some meaningful way. So I started a company in the early 18 to build a new software platform for devices. So I'm very much a software engineer, and I remain close to the code. I develop stuff, and that makes me happy. But I also really like sort of standing outside the big corporate giants like Google and trying to build something in context of a startup. So in a nutshell, that's me.
cool. Thanks for that. So what I would like to ask Kurt is, what are you working on right now on Toit, and in general, to quick overview and brief intro maybe would be great.
Yeah. So when we started Toit in early 18, my idea was really that writing functionality for small devices was something that most software engineers felt fairly uncomfortable with. So from a high level perspective, I think building functionality for devices that communicate with the cloud and do fun and interesting things is very attractive for software engineers. But the skill set required to build these things, to make it run on battery operatable devices and just make it actually work in practice, tends to require you to be like a firmware engineer more than just a software engineer. You need to know all the low-level details. So I felt that as a software engineer, that was just kind of wrong. I wanted someone to take this burden from me, give me a foundation for just writing logic, like real code, and just give me a way of deploying this on small devices. And in 18, I just realized that the devices that were available, like the ESP32 that we've been focusing a lot on, were clearly powerful enough to run even very sophisticated software. All it took was just like upgrading that like primitive real-time operating system that they come with to something that feels more like a real operating system, if you will, not real time, but real, like a proper one, something closer to what like Linux provides than what FreeRTOS or whatever the real-time operating systems are called. So our focus has really been on trying to enable software engineers, software developers, to do more on these small, you could say low-level microcontrollers, but do it in a way that still plays to the strength of a software engineer, make it possible to update the code on the devices, everything from the system software to the individual applications, make it possible to separate your logic into multiple apps that can be installed at runtime, and sort of deal nicely with all those hard things for you, so you can focus on getting data to your cloud. And late last year, we actually decided that it was time. Like most languages that have any kind of success, and Toit definitely has a programming language built in. I'm a language guy, so it's very natural for me to work on that. But most of those languages that end up having success, they are open source. So late last year, we decided that now it was time for Toit to also become an open source language, and something where we could see ourselves collaborating with lots of other companies, like including yours, Beray. I think the focus now is really on making something that enables others to integrate into their own systems, their own clouds, just be that missing piece of functionality on your device. So that's very much what is in my head these days, just making open source technology available for others to make them move faster and build better things.
Cool. Yeah, that's actually great to hear that. Because it makes perfect sense, not just as a founder in this space, but as also developer.
Yeah,
So that pops up different question in my mind because you mentioned programming language. It's another challenge. Updating devices is another challenge. So you are not just solving one, but also several side problems, as far as I understand.
yeah.
So what was the main challenge for you when we look at your past 3 years or 2 years? Which could be also business part, also technical part. That would be great to learn, also personally for me.
Yeah, I think it probably comes in two very distinct flavors. One is the sort of the low level part. And in order to build something that allows software engineers to not worry too much about writing firmware, we had to become great at writing firmware. So just like getting into the low level details of interrupts and GPIO and just internalizing how that all works out takes a little while, especially when you start looking into like cellular stacks with all the new narrowband IoT and LTE-M and all those technologies. It's a broad field. So to help others in this space, we had to become very good at a fairly large selection of technologies there. So that's one side. The language itself, I've been doing virtual machines and programming languages for a couple of decades, so it felt like that was probably the least of our concerns, something that we knew that we could do very well. So I think the other side is just the usual of when you introduce a new platform that sits at a very sort of foundational level, others have to buy into the idea of running on top of your platform. And when you're a small startup, sort of that the criticality of the work that we do needs to be there, but it's also like a challenge when you go out and say, go build your critical infrastructure on top of the code that I write. It requires a lot of trust from others, and clearly having a strong background helps. But at the end of the day, I think developers look at things that have success, look at things that are moving, and try to make a judgment call on whether or not to follow along based on those things. And that's always hard to bootstrap, sort of business wise. So it's sort of more the classical, how do you get from X0 to 1?
Yeah, right. Definitely. So actually, it's good to know. And so, what about right now? What's the vision? Where are you going from there? Because I know, and I will demonstrate, everything is up and running. Of course, I guess that you are fixing tons of stuff. There are things are under development, but where we would be seeing Toit in a year later, probably.
So we started out with a very sort of integrated feel to it. We actually at some point developed our own hardware as well, just to get a sense for how does it feel like to build a full product, to really sort of get our feet wet and understand everything from the hardware and up. And that sort of everything, that integrated platform also included like running a fairly big cloud infrastructure, and that has a lot of benefits, like being able to like run both sides of this, the device side and the cloud side, has a lot of benefits, but it also comes with the drawbacks. It's less general, it's less flexible, and if people come to us and say, I just want to run Toit code on my device, and I want my data to then flow to my server, so to my MQTT instance somewhere, this cloud thing becomes less useful in that context. It becomes more of a sort of nice for some, but not for all. And I think we've learned over the last maybe 6 months that there's a lot of super interesting opportunities for integrating into other cloud setups, other sophisticated technologies that are out there, if we de-emphasize the cloud part and focus more on being and something that is not fully integrated ourselves, but something that is fully integratable. So I think that's really the major shift for us. Instead of focusing on building everything ourselves, which I mean, in many ways, as a software engineer, it's a dream come true, right? You get to build across. It's truly full stack, right? On the other hand, it also comes with a lot of limitations because you can't build everything yourself. You need to like fit into an ecosystem and be a player in that. I think we just learned that, having spent time in this space for a few years, I think we understand it well enough that we can now start opening up and playing much better with others. So that's the main focus for us right now, opening the platform up, making all the good parts that we've built over the years like truly available and useful for developers out there to benefit from. And as an example, right, we're making it really really easy to run multiple applications side by side on these small devices, and we really want it to be like super flexible so that you could install an application that says I want all system logs from any application to go to my cloud, not Toit's cloud or not Amazon's cloud. And just making that sort of hookable and flexible, I think will lead to a lot of really innovative sort of new things.
Cool. Yeah,
So it's a
that's great. It's also,
opening up
yeah, it's
thing.
also, yeah, it was also the same for me as a team.
Yeah,
We learned a lot for sure. And we quickly realized that in specifically talking for IoT landscape, the best way to go is partnering
yeah,
because there are different major parts in the solutions. So I was able to observe throughout the years, many company tried offering everything as a bundle.
yeah,
Then now we see that easily, instead of doing that, just do, you know, just do something best, one or two things,
yeah,
and
yeah,
then integrate with the missing parts. And that's why we were able to grow faster in the
yeah.
coming
No,
months.
I think it
Yeah.
makes a lot of sense, right? And once you do that, then some of the things that have proven their worth in other settings, like open APIs and well documented, well described, declarative APIs, become truly valuable because that's the
Exactly.
integration points, right? I know you guys are doing a lot of that. We certainly are too, right? Trying to make it not our thing, but something that everybody can benefit from by making it open and controllable by others.
Right, right. It was also hard for us, but we had to choose where we are going to spend our time. As you
Yeah,
mentioned, as
yeah,
an early stage, it's hard. We
yeah,
we we were lucky to being able to choose the right things as far as we understand, which is documentation, examples. Of course, there are so much stuff to develop and improve, but at least it's not just a product. It's not just the features. It's also about being able to offer experience,
yeah, yeah,
which which covers the product documentation, integration, as you mentioned. Great. I will, of course, come back to the integration part and demonstrate how we
yeah.
actually work together. But I have a few more questions for you because
Perfect.
you worked on some deep stuff like programming languages, virtual machines, as you mentioned. Then you immediately switched to do a little bit different space, just for IoT in this case.
Yeah.
So, what do you think about the current problems in IoT? Not just what we are trying to solve or you, but in general, what do you think? How do you feel the market?
Well, I feel like one thing we've seen in the past, and this is very much me as a software engineer speaking here, so I'm sure that some people might disagree with this, but in my experience and what I've seen before is that over time, hardware and hardware near things tend to become a commodity. So that the difference between running on a new Mac with the M1 chip and running on an older Mac with a different chip is very, very limited, except that it's faster and better. But in terms of kind of the functionality that I can use on my new shiny Mac, it's very much what I could use like a year ago on an older Mac. So that means that for the server room, for the desktop, even for mobile phones, what we've seen is like a de-emphasis on the hardware. It's sort of shielded away from the logic, and I think we're still missing that to some extent in the embedded in the IoT space, where hardware and the connectivity, so the way we get bits from the devices and the way they sort of are physically put together is very much still the focus. And I think that is bound to go away over the next years. Now it's a big change, right? And I'm sure that when we had server rooms in the 80s, where people would code up against very specific like Sun hardware, um,
Right.
that this was still like thought of as the best thing, like low level C code on these devices. But I feel like we've seen that virtualization, higher level languages, they certainly have a room in that space. And now, I mean, it's less about what kind of actual hardware you run on and more about like Kubernetes and orchestration of services. And I think we'll see a trend towards some of that, at least in this space too. In terms of how the world then makes use of that, I still feel like we're pretty far from having devices that react well when circumstances like dramatically change. And IoT is hard that way, right? Because it's devices out there in the real world. So like network will never be as reliable as it is in the data center. So just writing software that's extremely robust to these things and still has a like rich functionality, not just forward random data to the cloud every now and then, but do more. I think that challenge is still slightly unsolved, right? It feels like my dishwasher is still not very smart, even though it's probably on Wi-Fi. But it's still, we haven't gotten sort of beyond that point. We see a few people like moving there, like Tesla is a good example. Like they produce a car, but it's also like a computer, and it's auto updatable, and they tweak your brakes while you sleep. It's kind of scary, but it's also very, very fascinating. I think we'll see more Teslas and fewer sort of old school car manufacturers in the future. And I think that tells you a story about what we'll also see in the more general IoT space. Does that make sense
Right.
at all?
Sure, of course. This is why we are here, right? We are trying
Yeah,
to solve the missing pieces. So
yeah,
I believe in the same, and at the same time, you made a good point. For example, when we look at the DevOps landscape, now it's more mature, more
mm,
tangible. But when we look at the IoT personally, I think we are just at the beginning in terms of
yeah,
experience, telling people, not just developers or large enterprises, they're explaining the benefits. The reason the term IoT exists is still hard, but I think we will be getting there faster than ever, which is good as a startup founder. So hopefully we will be seeing more examples, as you mentioned. So cool. And one last question from me is, you mentioned ESP32s, and I personally know you support them very well. Um, are there any plan that you are able to share for different platforms, or maybe something different that I don't know or I cannot imagine right now?
yeah. As a language geek, it's great to build something that runs across a variety of different hardware things. And we built Toit to run well on the ESP32, but certainly we also thought about other chips in that thing too. Um, so I think for me, like ESP32 is a great starting point. It's a fantastic little chip, right? It's impressive what it can do. But I think like opening this up, and it's one of the things the first thing we saw in the open source community was a great interest in broadening the support to run on more different chips, right? And we had an external guy contribute like a RISC-V port, which is sort of a future chip choice that might really become super valuable for us going forward. So I think, yeah, I think having a software platform that can run on many different kinds of hardware is the way to reduce the fragmentation caused by all this variation in hardware. So we're definitely gonna do that. I think sort of in terms of surprises that we might have in the making. My thing has always been performance. I love fast systems that react well, where you can build fantastic things on top because of the performance of the platform. So I'd love to get some time to optimize the system further and make it like 20 times faster than it is today. I think that would be fun and meaningful as people start using this for things that I can't even imagine today.
Cool. Yeah. Can't wait to learn more and implement together more.
Yeah.
So speaking of that, we talk about Toit and people may recognize what we do. So today, for the first time, I would like to demonstrate how it's easy to actually get the benefits of your open source tools and actually show the reason we built this integration. And of course, we will be talking a bit more about that from Toit part from you, hopefully, and I will be explaining more. So I would like to keep going by sharing my screen. So can you see that?
Yeah, it looks good.
Cool. So I just jumped to the Qubitro portal and I already created a simple project. We were using different device before. So what I'm going to is on Qubitro, I will just add a new device and this device will be connecting MQTT protocol and I will be covering the reason before later. Let's say Toit simulator. And let's say my desktop. So it's all from Qubitro to add device and access the credentials. Now, I would like to mention open source tool from Toit, which hopefully you will be explaining later more. But this way, I was able to pull the required tools to my computer and then access to Qubitra package. And after that, I was able to publish data. In my case, I was simulating data, but it's the same experience. So all I needed to was running this command line tool to install all the tools to my computer. And then I'm just now creating a virtual machine, let's say virtual device in this case.
Yeah.
And I will be getting some help from our documentation to show how it's easy to actually simulate and publish data. So in our documentation, it's available for Toit connector. I will be just copying and pasting this example. And thanks to Toit team, there's a package called Qubitra. And this package will be handling all the security TLS certification, setting more MQTT specific credentials, for example. And then I'm going back to the portal. I will just copy the ID and password. And this is actually a good way to demonstrate in real time instead of spending days or weeks on like other solutions. I will just save this code and I will just run the new one. I guess it was Q. Now it's offering me the virtual device and I sent the code. It should be running in every 2 seconds or second to populate data on Qubitra. So at the same time, I would like to mention you can visit Qubitra documentation to learn more. So let's pass this one. And as we see, it's just connected. You can click, expand here. So now I get the data. It's random, but we can easily access the data.
Mm-hmm. Yeah.
And even more, we can visualize, which is another step. So now we have the visualization of the data. And I can even do custom queries by using the calendar feature, or I can even do more right out of the box once we connect the device. So I will be jumping to our API playground. This is like documentation, but we call them playground because it's easy to test API without installing anything else. So let's say device is under my project. So now I'm able to access 2 devices on Qubitra. So I will not be going further for our platform features, but the idea is I was able to just simulate device on my computer. And thanks to Toit Qubitra package, I was able to connect securely to Qubitra and publish data as well. And after that, immediately, I was able to access device information and the sensor values itself. And then, of course, having dashboard charts or different solutions might not be enough for developers. So for that purpose, we offer APIs. So this is about the demonstration, but of course, we will be covering more with the Kasper, hopefully.
Yeah, it's cool to see it.
Yeah.
I think one important point is that like you decided just because it's very practical to run like the simulated code on your desktop machine. But the thing is that exactly the same code, your Q.Toit example, will run with no modifications on an ESP32, and you can get the code to the device over Wi-Fi, and it's the same experience on real hardware. And that being able to sort of be flexible there and spend your time looking at the data and understanding the visualization and the stuff, I think that's super slick, right? That somehow we've enabled you to get really far in what, 3 minutes?
Exactly.
That's a good combination, I think. Yeah.
And honestly, it didn't require any further setup. I just copied and pasting to install Toit tools, and I used the exact same command lines tools or commands. So as Kasper mentioned, this was good for me because I didn't have an access to real device, so that I didn't wait to purchase and get the access to physical device. but it's the exact same code that will going to run on the physical devices. And for that, we even have more examples on Qubitro blog. For example, um, our ambassadors and different developers already connected physical devices from different manufacturers to Qubitro easily. So I also would like to mention your package system because you support sensors as well as integration libraries as far as I know. So would you
That's true.
mind mentioning about them a little bit more?
Yeah, so I think one thing is a language and a core libraries and the virtual machine in there to run things. But in reality,
Right.
to help an ecosystem grow and help developers help each other, you need some sort of uh, common playing ground where you can share code and use it and run with that. And we've seen great success like with npm packages and Rust Cargo and like lots of other packaging systems. And we thought that the best thing we could do for Toit was also make sure that it came sort of out of the gate with a packaging system where you can go find drivers for your sensors, but you can also find integration support. So a Qubitro package that you can just fetch without having to worry about how it's implemented. You just get a high level way of connecting to the Qubitro cloud. And I think that's going to be more and more useful as more and more packages and integration support pops up there. So if you have a good idea on what to build in Toit and you want to share it with the world, publishing it as a package is a great way of making it easy to use for others.
Cool. Yeah, that's great. As I mentioned, I was able to just have my setup in a few minutes and test the integration. And I didn't have to install all the hard packages, software things, because in my case, I don't have time for that. And it's also getting more and more complex,
It
right?
is.
So I'm not able to follow up everything. So it was so easy for me. So I think it's a great way to demonstrate how it actually works,
Hmm.
thanks to Toit package and thanks to our library and integration. So, and the rest is just about idea, right? Developers just need to learn what they're going to build with
Yeah,
APIs or dashboards or integrations or packages.
that's exactly right.
Cool.
Yeah.
Yeah. That's all from me for today. It was great to learn more about you, more about Toit, and being able to demonstrate how our integration works. And hopefully, we will be doing this again. Hopefully, when we have more announcements, more features in near future.
Sounds
So,
like a plan.
thanks again for your time. Yeah,
Yeah, you're welcome. It was fun and it was great to see the full thing live.
right, right. So, I wish you have a great day and looking forward to speak soon again.
You too.
Bye.
Take care.